So hello everyone, and welcome to the live streaming edition of Serverless Berlin. For those of you who don't know me, probably, I come from Commercials. My name is Kim, and I am the Employer Branding Managers at Commercials. We are very happy today to be the technical sponsor of Serverless Berlin. So I have a co-host today, actually, someone who is more familiar to the community. And this is Anil. And hi, Anil, where are you right now? Are you in India right now?
Yes. Yeah, I'm based in India currently.
Okay, so it must be quite late at where you are right now, right?
Yes, it's I think it's evening, late night, 10:30 here.
Okay, so thank you so much for joining us, even though it's 10:30 p.m. So Anil, you are a product person. You're currently the product owner at Commercial, so probably you are the best person to ask about, what is Commercial's product?
Well, I think Commerce Tools is like we give our customers a commerce platform technology of the kind you find in companies like Amazon or Zalando at the fraction of cost compared to building that in-house. In addition, we provide tools to our customers so that they can customize, extend, and build their dream business workflow.
Mm-hmm.
I'm really excited about today's talk, how you can use the power of headless and serverless to build great applications to customer business needs. Yeah.
Yeah, so as I know that you are the one who encouraged James and Nicholas to take part in the Serverless Berlin meetup. So what exactly is like the thing that you find interesting about this particular topic?
Yeah, for me, as you know, that Commerce Tools is the inventors of headless commerce, and the power with the headless approach and how you can extend different commerce capabilities and how you can really scale using the serverless functionality quickly. And that was kind of really excited me, and the work which Nick presented in one of the blog posts.
Mm-hmm.
And that's why I thought it's a great idea to share with the community, especially for the Serverless Berlin meetup community,
Mm-hmm.
so that our other community members also can get benefit, and how we are doing at Commerce Tool, providing our customers possibility to extend using headless approach and serverless approach.
Yeah, and that is actually a very interesting information. Not a lot of people know that our CEO Dirk is the one who invents the term headless, which is so popular right now, not only in e-commerce but also in other kind of software industry as well. So thank you, Anil, and again thank you so much for joining us. Even though it's 10 p.m. your time right now, I will give you a little bit of a break, and I think it's time to get to know our two speakers from Durham, which is James and Nicholas. So,
hi Kim, hi Anil. It's good to be here. As you said,
hi Nick and James.
We're from Durham, North Carolina. So as opposed to 10 p.m. in India, over here it's just lunchtime. So good timing for our part.
You. So yeah, so Nick and James, welcome. And probably if it weren't for Corona, let's put it this way, we wouldn't have seen you here at Serverless Berlin. And so a big welcome to you. So James and Nick, could you tell us a little bit about yourself, like your background? James, you are like a solution architect right now, and Nick, you are the senior full stack developer in Durham for Commercials, right?
Right. I work, go ahead, James.
Oh, thanks. Yeah, I'm a solution architect currently. I've been doing, e-commerce since around 2005, always in the tech space, whether it's programmer, architect, or basically just building code. So the current job is at Commerce Tools. It's been a great experience, and I hope it continues. Nick, let's jump in.
Yeah, I'm a full stack senior developer at Commerce Tools. I work on the professional services team currently. Mm-hmm. So I've done some customer implementations, and I currently work on supporting our partners and existing customer implementation. Live data.
Yeah, great. And just by the way, for those who are watching, we're in the same company, but this is the first time that I ever collaborate with James and Nick. So also a pleasure to get to know you folks. So yeah, I'm a little bit curious about your exposure with serverless. So is this your first time working with serverless at commercials, or have you already had previous exposure before? Nick, you can go ahead and answer first.
Sure. So my first exposure to serverless was about 5 years ago at IBM. We started on developing their serverless cloud, the IBM Cloud Functions. It started out as an open source project called OpenWhisk. So I worked on some of the core components with the controllers and testing those pieces and the connections there, the things that are going on behind the scenes with serverless, the containers, working on the DevOps aspect of keeping everything running and making the sample applications and serverless applications on the IBM site. And then that transitioned my role here, where we do a lot of serverless to handle events that are going on your e-commerce platform and commerce tools and responding to that, send emails and work with APIs.
Okay, so you're definitely like a veteran in terms of serverless. So James, what about you?
Yeah, I'd also say I'm a veteran. I am probably one of the first adopters of Amazon's Lambda services. At the time, we were doing an email marketing application that used their SES email service. And we leveraged Lambda to try and improve the throughput so that we weren't sending full templates, but one template and the list of emails, and using Lambda to process those SES sends. Since then, I've been using serverless for all of my asynchronous tasks, on whether it's side projects or recommending it on professional projects. And I think just recently it's come into its own for all purposes, not just anything background processing. And so the project we're going to talk about is my first experience using it for all pieces of the puzzle as opposed to just background processing.
Okay, so it sounds very exciting, and yeah, we're very looking forward to hearing your talk. So I will give you a few moments to prepare. For our viewers right now, I just want to remind you again that the talk is going to take about 40 minutes. Afterward, we're going to take 10 to 15 minutes for Q&A. During the talk, please feel free to add any comments, add any questions you have in the comment section, and at the end, Anil will help us go through every questions one by one. So yeah, that sounds great. Let's listen to James and Nicholas talk.
We're excited to talk to you about one of our recent e-commerce projects for tire discounters. So the tire discounters project was unique in that it was a very quick job with a small team that was prompted through COVID-19. However, a lot of the patterns we used and the technologies we leveraged could be applied to any project, regardless of the circumstances. For tire discounters, the COVID lockdown required them to provide their customers a touchless checkout system. They needed a way for their customers to get new tires and services without having to go into the store and talk to people within that 6 feet barrier. And like most companies at the time, they needed this functionality ASAP. So we assembled a small team of about 4 tech people and went to work. What could we build? Thankfully, tire discounters already had a lot of pieces in place that we could leverage to speed things up. One of the things they had was an existing website. This is a legacy website. It was PHP. It had some Angular on the front end, but it did have a lot of great features, like the ability to look up tires and pricing. It had the product catalog in it. It also had their store base, so you could go in and look up a store and find a location where you can get the service done. And that was great. There was a lot of information there. They also had Salesforce installed that they could use for customer management, and in the future could use for managing those orders between the different store locations. So these are 2 tools that we could look at using. Tire discounters had also signed up for Commerce Tools. Commerce Tools is an API-first commerce platform. It's fully headless, it's built on microservices, designed for the cloud, and it is a 100% hosted SaaS solution. They had signed up for this service prior to COVID-19 with the plan of an entire website makeover, where they were going to take on a big project of rebuilding it with e-commerce in mind. Thankfully, Commerce Tools is very flexible. So instead of building out the entire system, where other monoliths might require us to move the products into it, the customers, and build everything in that one system, with Commerce Tools, we were able to pick and choose exactly which pieces we need and reuse the pieces that they already had. And that's what made this project fast and possible in the timeline that we had. The other great thing that Commerce Tools brought with it is a large open source ecosystem. There's a lot of open source code that we could just grab off of GitHub and fully leverage for this project. One of those pieces is their Sunrise open source website example. This is a full e-commerce website written in Vue.js as a single page application. We grabbed this and kind of took it apart to leverage the pieces we needed. Specifically, we needed a checkout funnel. From their old website, they already saw the products. Now we needed to get them into a cart and through checkout. So those are the pieces we used. On top of that checkout funnel, we needed an integration between their existing website and the Sunrise instance that we were going to set up. We needed some backend APIs to help power that checkout. And we needed to move data around. As is often in a modern commerce solution, we needed to get the data between the different systems that were in play. So in this case, one example was moving orders from Commerce Tools into Salesforce. So now came the fun part, figuring out which tech we were going to use. The team building this was familiar with Amazon Web Services, so we decided to choose AWS, and we all had access to GitHub. So those were very easy choices to make. We're going to use GitHub for hosting our code and AWS for hosting all of the services. A harder decision to make was how we were going to host those services. A lot of us had experience with Kubernetes, Elastic Beanstalk, or even just setting up EC2 instances. But we started researching other options, and we settled in on using AWS Lambda, driving that functions as a service or serverless model for this implementation. We did that because Lambda comes with a bunch of pros. The first being less operations, less maintenance. This was a small team, and when we were done with the project, we were handing it off to another small team that was already pretty well leveraged in running the Tire Discounter's website. We didn't have the ability to hire people to help maintain this website and keep it running after the fact. So those lower operations was a big win. It also had built-in scaling. Tire Discounters had never had an e-commerce funnel on their website. We had no way of knowing if it was 1 order a day or 1,000 orders an hour. So we had no idea how to scale up the resources, and this auto scaling helped. We've got that high availability, resilient to DDoS attacks. It also mitigates errors. We had a very short timeline, and when you're building things fast, errors tend to get introduced. And if you're building a basic monolith, a single error that builds up may take down the whole website. Or maybe you have a memory leak that eventually just crashes your server. With AWS Lambda, if you have that error, it's going to take down that specific function that's running, but a whole bunch of other ones can be spun up in its place. So it's not taking down that website, it's taking down that one call into the function, which is great. And for people with variable usage or unknown usage, it can save a lot of money in that it's going to scale up and down, and you're not going to have to pay for more than what you need. For everyone out there, there are some cons to AWS Lambda. Some of the cons being a risk of cloud lock-in, cold starts. When a Lambda first kicks off, it has to build out that container and get it running. So that first call tends to be slower than the rest, taking upwards of a few seconds. If you continue to scale up as it builds out more containers, you get more cold starts. That's a known thing with Lambda, but it continues to improve. There's a concept of denial of wallet attack. This is probably going after bigger companies, but if someone really does want to attack your website and they hit you with a DDoS, instead of taking the system down, now it's just blowing up your AWS bill. So you end up with this huge bill that you can't pay, hence the denial of wallet. Thankfully, AWS does have some systems in place to both alert you and limit the amount that can be spent to protect you from these types of attacks. There is some lower flexibility here in terms of your execution environment, your execution time, and so on. You're basically running within their preset container, and you don't even get to know what that is. It It's not like you're installing your own Linux distribution and get to control every aspect of it. They control every piece of that execution environment and you get to play within it. Local development can be a little bit tougher than other systems. Part of that being that you don't necessarily know the execution environment, but there are a lot of tools that can help. And if you have a really high volume website, Lambda's probably going to cost more. A single CPU cycle on Lambda costs more than a single CPU cycle on a reserved EC2 instance. But if you're talking about an unknown or variable load, this higher cost often doesn't come into play. When choosing how to use Lambda, we went with serverless. Our main drivers at the time were that it's the most popular framework for using functions as a service. Many reports have it at 65% adoption, and that it has a large ecosystem of examples, code that we could leverage, or plugins that we can use during the process. So let's get to it. What did we actually build for tire discounters? The first thing I mentioned is that we need an integration from their old website to this new checkout funnel we were building on Sunrise. To do that, we made some services on Node.js, specifically one microservice with an API gateway in front of it. That microservice connected to commerce tools. So the existing website could call out to the REST API and say, hey, I've got a customer here. This is the store they've chosen. This is what they're looking to purchase. That microservice could then initiate a cart with commerce tools, add the relevant information to it. It also created an anonymous token that could be leveraged on the single page application, a token that was appropriately scoped for something running within the browser. And then they could get kicked off to that checkout funnel to finish their flow through the website. On the other end of the spectrum, after they were done with the checkout funnel, we needed to create a system for moving orders out of Commerce Tools into Salesforce. So we used a very common asynchronous event-based approach. So you see this very often with modern architectures where you're triggering events that go into usually a queue, and then those events are processed. This is a great way for moving data around, for handling anything that's not live with the customer. So here, we tied into an existing Commerce Tools functionality where Commerce Tools has subscriptions that can trigger directly to an SNS. That SNS immediately kicked off an AWS Lambda, and that Lambda written in Node.js used some Salesforce APIs to push the order into Salesforce. This is a great paradigm to use. If Salesforce were, let's say, to go down, it's not a problem. We can rerun the queue events through the Lambda. We can turn off the Lambda and let the SNS queue hold the messages waiting for Salesforce to come back up. Or maybe we're getting too much traffic. We can add some throttling to that AWS Lambda to better manage the full system from beginning to end. Because this Lambda is a single piece of functionality, we can see exactly what's happening with our order sync without having to analyze the rest of the application. Speaking of the rest of the application, let's put it all together. We leverage CloudFront for all requests coming into AWS. CloudFront, you probably think of it as a CDN, but it's also a great way to route traffic. It's also a great way to make sure that your requests are coming to the edge of the network, to the closest location, and then utilizing AWS's infrastructure to get across the world. That CloudFront instance channeled some of the traffic to the new single page application. For that, we hosted it as simply as we could. We put it in an S3 bucket and turned that S3 bucket on to website serving mode. This is not a great way to host a single page application. It doesn't allow for pre-rendering. It doesn't allow for many good SEO features, but it is very fast to set up and it's foolproof when it's actually running. Because we were just doing a checkout funnel, we didn't have to worry about those SEO concerns. If you were doing another e-commerce project where you did, I would strongly look into one of the services for hosting single page applications, something like Netlify, or at least having a container or another Lambda in the background doing that pre-rendering. That single page application uses the token that was generated for it and connects directly to Commerce Tools, in this case through its GraphQL API. GraphQL giving you more power on the request and the response and keeping things slick in the browser, especially when you're on a metered mobile connection. CloudFront also intelligently routed some of the traffic through to the API gateway that we had set up, which had all of the Lambda services behind it. So it had that node service for connecting the old website to the new website, as well as some other services running in the background. And those services also connected to Commerce Tools. In this case, they had their own key and secret. It was at a more elevated scope than the single page application, since it was secure on the server side. And all of the connections there, we actually used the Commerce Tools REST API. As I mentioned before, we had events being triggered. Those events coming out of Commerce Tools into SNS queues as needed. The one I talked about was the order event, which was driving through that event processor in AWS Lambda and pushing orders into Salesforce. And you can see from the dotted lines that those events were asynchronous, while the rest of this has been synchronous. And all of these services are logging and pushing out messaging, which is going into CloudWatch. CloudWatch is a great tool for aggregating all of those logs and messages and giving you an insight into what your overall system is doing. Through CloudWatch, we also set up some dashboards to give a quick view into it. And we set up some CloudWatch alerts that trigger emails at necessary times. This can help drive an on-call behavior as errors spin up within any of the different services. So getting into the code and outside of the cloud, we put all of our code in GitHub, as I mentioned. Instead of setting up different GitHub repositories for each and every piece we deployed, we used a monorepo. Monorepo, as its simplest level, is basically a set of folders inside of your GitHub repository. Often these folders are referred to as packages because people that build a set of related NPM packages often go down this monorepo route, but it is a very useful way to avoid setting up a lot of repositories, especially when you're building these small functions as a service or these small microservices. You don't want to have to set up all these different GitHubs and manage them all separately. So within that monorepo, we also used a tool called Lerna. Lerna is available on NPM, and it hypes up that concept of folders, of that concept of a monorepo. Lerna allows you to run a command across all of those different folders or packages at the same time. Lerna also gives you a lot of advanced options like sharing code between them. Though we didn't get a chance to utilize that functionality in this project, it's really a great tool and I highly recommend it. So then if you look at the root package.json, you can see that we have a set of scripts that we can run. And all of these scripts are calling Lerna. So if we want to build the entire project, we can call npm run build, or in this case, yarn run build. And that will then execute Lerna exec yarn build, which turns around and runs yarn build within each of those separate packages. So we're calling it once at the root, and Lerna is calling it through every individual package to make sure they all get built and the entire project gets built. Microservices or these small snippets of code might seem daunting at first when you're coming from that monolith world, but with tools like Lerna, it's much more streamlined. And you can see we had the typical set of scripts where you can build the project, lint it, run the tests. And then we also had deploy and remove to deploy the entire project or basically pull it down and shut down the entire environment. And we set that up for dev and production. Within each of the folders or each service, we also had a set of steps. So you could have a build step. We had a lint step. We had a testing. We used Jest for testing our node code. Then we also had a dev, which wasn't called from the root, but it was good for executing locally. We used that serverless offline plugin. And then the deploy and remove for standing things up or pulling them down. Finally, for a very basic CI/CD pipeline, we utilized GitHub Actions. GitHub Actions came out a little more than a year ago and has gotten a lot of buzz since then because it's very easy to use. Basically, certain events within your GitHub repository can kick off your GitHub Actions, and it's running on a container on a server, and you can do what you need to do. So here you can see we have a GitHub action for anytime someone pushes code up to the repository, and we called that build. It's running on an Ubuntu server. It's leveraging Node.js, and it's running the steps on the right there. You can see it runs install. It runs build to build all the different packages, lint, and test. And it's running these at the root. It's running that root package.json, which is then calling Lerna and running each individual package concurrently. So it runs yarn install, and all of the packages are running their install script. it runs yarn build, and they're all building at the same time, which is great. And as I said, this runs anytime someone pushes code in. So it'll show up in your pull requests, whether this passed or failed, to make sure that code doesn't get merged in that hasn't been properly linted or tested, or that just fails to build for whatever reason. We also add actions that, again, kicking off on push, but here we're leveraging GitHub's conditional statement. So you can see that if commit statement on the left side. So if the reference is develop, so basically if they are pushing into the develop branch, then we're going to run this code. And on the right, you can see, okay, we're running install, and then we're running deploy, which is going to use that serverless framework to deploy all the code into the dev environment. You can also see on the left there that this step needs the build step to execute. So if build fails, this step won't even attempt. It will also wait until build is finished before kicking this off. So there you go. We had a great environment set up. We've got our microservices running in Lambdas. We've got our events being kicked off and processed through AWS Lambdas. Everything's auto scaling the way we need it to. We've got a basic CI/CD pipeline pushing code as we make changes and fixes, and everything's perfect, almost perfect. Running a single command on the command line will kick up an entirely new environment. I can run deploy stage and have a new staging environment set up, or deploy James and have a custom environment on AWS just for me. And it would basically set up all those AWS resources, deploy all the code, but it didn't connect the Commerce Tools events directly to the SNS queues and the other code that was needed. I could go into Commerce Tools and say, okay, let's use one of the systems already available, like Terraform, or just make the API call directly, write a little curl script in our CI/CD pipeline, and that would connect everything. But it didn't feel like the serverless model. So instead, I went back to the team and I said, hey guys, this is the problem we hit. What can we do? And that's where I'm going to kick things off to Nick to take over for me. Thank you.
Welcome to part 2 of Serverless Ecommerce, how to leverage APIs, events, and microservices. I'm Nicholas Speeder. I am a full-stack software developer at Commerce Tools. I work on developing enterprise e-commerce implementations, as well as supporting existing customer implementations and helping to guide partner teams in their development. Attached there is my LinkedIn and Twitter. Next to that is James Luteric's LinkedIn and Twitter. Contact us for links to more code examples and modern cloud e-commerce questions. My LinkedIn has links to the Medium articles found later on in the recipes portion of this presentation. This half of the talk will cover an introduction to the serverless framework, its features, and how to use Commerce Tools with serverless. I will go over the Commerce Tools serverless plugin, how to use it to deploy subscriptions and API extensions. This will lead into some modern e-commerce serverless recipes, and then we will end with open questions. Check out serverless.com for the Serverless Frameworks website. It is a good starting point to sign up for serverless for free and install the CLI on your local machine from NPM. From here, you can create a new service or install existing services, deploy the cloud functions, invoke, and test. Why use the serverless framework? It's to increase your development velocity and allows for fast and painless cloud function development. It provides a set of best practices and tools, as well as testing, CI/CD, monitoring, and of course, scaling. It's very easy to set up and deploy with the serverless tools. You can connect to your AWS and GitHub accounts, deploy and test from there. There's no need to config shell scripts, test commands, dependency installations, and config files in your repo. Serverless CI/CD uses the serverless YAML file in your repo and automatically configures tests and deployments from there. It's very easy to test locally by invoking the local Lambda command using serverless invoke local. From there, you can utilize API gateways to deploy to AWS or other clouds and have endpoints through the API gateway. You can easily create, publish, secure, and monitor your REST APIs at any scale. It's very easy to connect to serverless functions route HTTP requests to Lambda functions from here. Simply go into the Lambda console designer, click Add Trigger, and choose API Gateway for your Lambda's trigger. A new feature of the serverless framework is the Event Gateway. It is a new project that helps manage events happening in your serverless application. You can use the gateway to test locally and use events from other clouds. For example, you could have one event fire from Azure and then trigger a Google Cloud function. One example would be reacting to a user-created event in one cloud, and then any of your events can have multiple subscribers from any other cloud service. Lambda can talk to Azure, which can talk to Google Cloud Functions. You could respond to a user-created event in a Lambda by doing some follow-up processing. The serverless framework also allows for different stages and testing. There you see the serverless framework dashboard. You can remotely invoke Lambdas, perform unit tests, integration tests throughout the stages, and event mocks. It's very easy to preview your deployments and perform auto cleanup. The serverless framework will automatically deploy changes from pull requests to a preview stage so that your team can view the test results, deployment statuses, and test out the services. Serverless will keep your environments lean. When you delete a test branch, your services will automatically be removed. Serverless has a CI/CD workflow guide on their website where you can see how to easily use their monitoring through the dashboard to set roles and logs. The dashboard tracks your service's health so you can easily see errors, cold starts, timeouts, invocations, and request patterns. From here, you can configure alerts and logs. On deployment, serverless will automatically instrument your services so you can deploy with confidence and use a deployment tracker to see when your changes influence performance. You can scan the deployment streams, open reports to view policy compliance, output variables, and deployment logs. The serverless framework's monitoring smart alerts and graphs will take you straight to exact log sections, function spans, and stack traces so that you can easily resolve your issues. Next, I'm going to demo the commercetools serverless plugin. We recently developed this to ease the deployment of commercetools resources after the creation and deployment of a serverless function. It allows for one command deployments for your serverless e-commerce code. I'm now going to show the API extension demo and walk through a serverless YAML file configuration. The first step is to install serverless and then create a serverless project. And then, of course, install the commercetools serverless plugin. Set your cloud credentials, and then you will dive into your serverless YAML file. Within your serverless YAML file, you're going to want to set your cloud provider, your environment variables for your commercetools client, project key, etc., and your post body, which will have your triggers, in this case, cart, create, and update. After this, I ran a serverless deploy, and this allowed me to deploy a Lambda function. And when it was after the deploy of the Lambda finished, you can see there that the commercetools extension was created. There's the Lambda ARN, and then you can see the resulting body ID from the extension's creation. You can see the created date, the version, the client that created it, the destination, which is the Lambda ARN, and the triggers being the cart actions of create and update. So there you have it. There was a deploy of a Lambda to AWS, and then the creation of a commercetools API extension following that. I am now going to demonstrate a subscription deploy. using the Commerce Tools plugin. First, you need to install Serverless, create a Serverless project, install the Commerce Tools plugin, and then set your cloud credentials, AWS key and secret. Then you can dive down into your Serverless YAML file to set the CTP post body, which is what we are posting to Commerce Tools. Here you can see the provider is AWS, the environment variables with the CT client information, and then the post body to the SQS queue and research type order. Once again, I run the serverless deploy from the command line, and then you can see in the end, after the deploy of the Lambda, there's a subscription created in Commerce Tools. You can see the result body is a success with the ID, the creation date, the destination being an SQS queue, the URL to the queue, and the messages being order changes. You can set up these queues in your YAML file to connect to your serverless function. And then whenever a Commerce Tools event happens here on the changes to order, they will be pulled from the queue into the Lambda and processed. The Serverless Commerce Tools plugin hooks into serverless lifecycle events and commands in a JavaScript class. In this case, it hooks into the deploy did finish function for Lambda and GCP cloud function deploys. After the functions deploy, the callback goes into the plugin's code to assemble the ARN and post to the Commerce Tools API to create subscriptions or extensions based on what's in the serverless YAML file. You can find this plugin on NPM and serverless.com. Serverless.com has a plugins page where there are thousands of plugins to get you started and to help ease your development. There are things from AWS CloudWatch alarm setup to plugins that help prevent cold starts, forward logs, emptying of S3 buckets, and there's even one that bundles your Lambda functions with Webpack. The GitHub link there is a link to the open source repo. It's a good starting point if you're interested in getting involved with open source and serverless. Feel free to pick off a couple of the open tickets there and start coding. The Medium blog post at the end there teaches you how to go through the serverless YAML and configure the Commerce Tools resources. I'm now going to go over some serverless Commerce Tools recipe. The acronym MOC allows for modern e-commerce extensibility and development. The MOC standard, which is core to performance and flexibility of development for businesses and the user. MOC stands for microservice-based, API-first, cloud-native, and headless. This allows us to navigate complex modern technologies from web to mobile to IoT. The first recipe I'm going to show off here is order confirmation. This involves the creation of a Commerce Tools subscription from the plugin, which will listen on order events. You can then send a confirmation email to the user when their order is completed, or even to your business users. You could listen on any Commerce Tools events and have an internal system to notify your business users via SendGrid email of Commerce Tools platform events, such as a new offer going live in your e-commerce system. A second recipe here is for cart verification. This is an API extension, which you could create via the plugin. You can check for the max number of items in a cart. For example, you can make sure there are no more than 8 crates of a beverage that can be ordered at once. You can then calculate custom shipping costs and add in mandatory items, add in mandatory insurance. This all happens before the API returns to the client. It is in the middle of the API and platform call and an API extension. The MOC system also leverages modern technologies such as chat bots, the Internet of Things, and social. The first example is voice. You could create a Lambda to integrate with Alexa skills. And as you speak to your Alexa bot, you can have an order flow going through a serverless function to respond to the commands, cart items, and then order them to your address. Similarly, you could have a chatbot where you are typing these responses to the chatbot and the Lambda is handling the orders in the background. You could even integrate with smart home apps, like if you have a smart refrigerator with an interface to order more filters through your refrigerator for your refrigerator. Another example we did with serverless was an Instagram backend piece where we could handle loading Commerce Tools products into the Instagram catalog where you can sell on Instagram. A final example is connected cars. You have a car interface where you can order in-car purchases through the interface or through your voice. You could order parts for the car or any other item that you can think of. This would all be created using a serverless backend. You could use the API gateway for this service layer. This brings us into the Commerce Tools SDK that you will use on these backend services. There's a JavaScript SDK, a Java SDK, PHP, and .NET. There's even a iOS Swift SDK. And there's a Postman collection where you can utilize the API to fetch your data and post data to Commerce Tools through that Postman collection. Another recipe I want to show off today is an augmented reality app that we made. It utilizes a serverless layer where there's a set of serverless functions and a serverless layer to retrieve products from Commerce Tools, display them in an AR view. To do this, you would extend the product data model to have an attribute definition, which is a field pointing to the AR resource. This is off the product types in Commerce Tools. You could utilize extensions and subscriptions throughout the application's flow for cart verification, order confirmation, etc. Commerce Tools has a integration with 3Kit. The link on bottom there is to the Commerce Tools marketplace where you can check out this integration to store your 3D augmented reality product catalogs and use them in your apps to view your products, cart, and order them. Following this, we created a virtual reality application with our partner Valtech, which was demoed at Shop Talk, where you could put on your VR headset and walk around a house and cart the furniture items in the house and order them. The menus there were all virtual that would pop up, and you could click to add the items to the cart and then view them in the Commerce Tools Merchant Center or on a mobile app once you're outside of the virtual reality experience. Once again, that could use Commerce Tools subscriptions and API extensions and a serverless layer to interact with your cart and commerce information. Here are the links to these recipes. The first is the AR Tech blog on Medium. The second is the VR Tech blog on Medium and the Commerce Tools Tech site as well. The third is a subscriptions blog by Dev Gurus, who are one of our partners. The fourth is an API extensions tutorial up on the Commerce Tools documentation website. The second to last there is an Apple Watch link that shows how you can utilize GraphQL to create an Apple Watch app to cart and order through Commerce Tools. And finally, I put a link to the Amazon Alexa skills in a Lambda so you can use serverless to interact with voice e-commerce. Are there any questions on serverless commerce tools, API extensions, subscriptions, and their applications?
Yeah, I think it's thank you, Nick and James. Great talk. I guess we have Kim. Do we have any question on the stream?
It doesn't look like it. Maybe they're still
Okay.
coming in. There is a delay.
Okay, just a reminder for those who are on the live stream, if you've got any question, please let us know on the chat window. And meanwhile, I got a couple of questions to Nick and James. Can you tell us from your experience building these serverless applications, what are your key takeaways? For example, like what is the do's and don'ts you would recommend for someone who want to start considering serverless and building some serverless application for their business use case?
Yeah, I think the cloud today, it's a much different beast than when it first came out. And there are so many offerings out there and so many options that you have to go down that before you even decide to build something, you need to really evaluate what you're building and what the expected traffic for that, item is going to be. You need to do that before you can decide whether serverless is the right route or whether you need, some container service or something that can handle, a huge amount of traffic at a lower cost. As I said, serverless can be very inexpensive for these side projects, and it can manage your costs because it scales up and down by itself. But if you're a massive website just driving tons and tons of users, you probably want those reserved resources available to you because you are getting them at a lower cost than Lambda, where you're paying for the privilege of having that no ops experience. So it's kind of weighing, is it worth paying an ops person to manage my stuff, or is it worth paying one of the clouds to deal with serverless? So those are definitely some do's and don'ts. Nick, you have anything to add?
Yeah, in my experience, like James said, if you're looking for no ops, you provide the code and deployment, and then you have the hardware and patching abstracted away from you. If you want that, go with serverless. If you're looking for something to handle messages from queues and Commerce Tool subscriptions, sending emails, syncing products on their database, sure, go with serverless for sure. On the development side of things, I would say limit the scope of your functions to one task. You want to test, these module or smaller code pieces to keep them clean. You want to version them, check your memory allocation settings, keep your secrets out of source control, limit the access to your secrets, use separate secrets for different application stages. And as far as don'ts, another don't is don't run like long-running machine learning type crunching tasks in serverless. That's not a serverless use case.
Yeah. I also point out that, I mentioned that in serverless, you don't get control of your environment, which means it limits you on the languages you can leverage. So it needs to fit with what your development team is comfortable with. If your entire development team is full of Java developers and the serverless platform doesn't support Java well, go with something else. It's better than trying to completely relearn a language just to fit into a paradigm. So.
Great. Yeah, I think those are the great tips I can say. James, I think one of your presentation, you talked about the local development. Maybe James and Nick, can you share us the hard parts where it's get really tricky for the local development? And of course, I think you mentioned some alternatives for that. Can you talk us about what are the challenges with the serverless when you want to build locally, you want to test locally?
Mm-hmm. Yeah, so there's some great plugins that the serverless framework gives. Serverless Offline is the most popular one, and it does a really good job of giving you a local environment for running your API services. So you can stand at the API, you can call it from whatever application you're calling it from and test everything before you deploy it. However, when you start getting into these more complex systems where you have this event-based approach and you're connecting multiple fast objects together through multiple SNS queues or SQS queues, now you have a lot of pieces that you have to put together. And that serverless offline doesn't really help you to test the entire piece in full. It lets you test one piece at a time, but you can't really orchestrate the whole thing without actually deploying it. So I've noticed that a lot of people have just skipped the local development and they're using some online code editors now that AWS and GitHub and others are offering to say, I'll just, write my code in a browser because then I can just use the resources that are out there rather than trying to get this all up and running. So yeah, you can get one piece at a time working, but it's hard to get the entire, application up and running by itself.
Yeah, you certainly do have to test everything up live in some environment at the end. But as far as local development, you can use things like AWS SAM local, it's a CLI tool to test Lambdas locally. And of course, the serverless invoke command, invoke local. So if you want to run the code in your local editor and test out what you're doing locally with the payload.
Yeah. And I'm wondering if it'll get better. It just got announced this week that AWS Lambda now supports Docker containers. So I don't think really anyone understands how that's going to work yet. But Docker's always been a great way to say, okay, it works on my machine in the Docker container. I'll just ship the whole container to make sure it works live. Whereas right now, all these tools are kind of guessing at what the live environment looks like, trying to replicate it locally. So hopefully that will bring some changes that may help.
Yeah, that looks really exciting news. My next question is, I think it was a really great example from Nick, all the different recipes. Did you ever face issue with when you want to persist some state? Yes, you execute some of the code on the serverless function, and you're done. Have you ever had a challenge of you want to persist some data?
Yeah. So is this the idea of persisting state through Lambdas? Basically, functions as a service, they're stateless. So if you want to maintain state that persists between the Lambda invocations, you're going to want to store the state externally in like DynamoDB or Elastic Cache. There's a temp directory, or there used to be, at least in Lambda, where you can persist things in a temp directory that you'd want to clean up. Usually you want your Lambdas to be sandboxed. There's a async hook API where you can store a global state, but that's kind of an anti-pattern that should be avoided. You really want to use something like DAX, DynamoDB Accelerator, AWS Elastic Cache, Redis Memcache. There's Amazon Aurora Serverless. It's another database they provide for that capacity. There's serverless key value stores like Amazon DynamoDB, Google Cloud Data Store, IBM CloudEnt. And you can use the API gateway to cache for a time to live period to cache responses.
Yeah, Nick mentioned the in-memory temp folder within AWS Lambda, which is a great way to basically store things between executions, so you don't have to get it every time, but you have to consider that a cache, not a state, because it can be deleted or not there at any of your next invocations. So I think Nick's right. It's changing your mindset to get into a more stateless flow and putting all of your important data into some other service that can be relied upon and backed up.
Mm-hmm. And queues are always a good pattern to use between systems and between clouds. You can push and pull from SQS queues.
Yeah, okay, thank you. That sounds good. Did you ever had any challenges with the security with using the serverless apps, especially you're calling and you're connecting to different systems? Like the example from James, Salesforce connecting to a single page application, to and fro, there are different communication is happening, API gateway. What's your impression, and can you tell us about the security concerns while building serverless applications?
Yeah, that's a big question, and it's definitely an issue that you need to keep track of. You always want to go with that approach of the lowest possible privilege for everything that you execute. And sometimes AWS and other clouds make it hard, where you're just like, I just want to give it all admin because then I know it will work. How do I do this? How do I give every single piece of the puzzle its own permission set and actually manage it? I do think there are a lot of good templates that'll help you along the way. But that temptation is always there to say, I'm not gonna mess around with these permission systems, and I just want to make it admin. I gotta be honest there. So overall, that is a challenging part of the project, and I think you just gotta keep doing it until you get used to it, because it does get easier over time, and also realize how important it is to keep everything secure and locked away. The other thing that I've seen people do when they start off with these functions as a service is they want to basically just hard code all their credentials into the code because it's easier to deploy. And that's also an anti-pattern because now it's out there in the world. Even having it as environment variables for the execution can be a risk because now if you can log into the AWS console, you can go and retrieve all those passwords. So you really need to put it into a password store or have some type of system that's issuing tokens for you.
Yeah. To add to that, OAuth is the standard. There's a flow on the Commerce Tools docs on to how we handle the OAuth tokens and external OAuth as well. I basically say for basic serverless security, separate your lambdas, lock them down, permissions based on the roles like IAM policies for permissions over resources in AWS. You have each lambda locked down to do one thing. Set your policies per that lambda. Check your IAM policies to give the least possible privileges, as James said. Perform that specific task. And you can also put the lambdas behind a API gateway, which can prevent dial service protection, the rate limiting, integration with authentication as a service. Providers you can use like Cognito on AWS. And then, of course, follow the standard like OWASP rules with web application security, like the top 10 in SQL injection onward. And always watch and monitor your services with logs and monitoring services to see what's going on.
Great, great. My next question is more on the direction of like, as at the Commerce Tool, like we are the inventors of headless approach. I think Nick also touched about the Mac stack for us. And how do you see serverless fit into our approach, and how it benefits if anybody wants to use the headless approach?
Yeah, so the headless approach basically is responsible for back-end processes, calculation, and data storage. It exposes the data through the Commerce API and Commerce Tools, so it makes it possible to attach all kinds of front ends, the heads from websites to mobile apps, voice, IoT, the car scenario. And serverless certainly fits this approach with its modular design. You have the ability to create microservices, which can be easily attached to different front ends and utilize these serverless functions throughout all kinds of other systems from back end to front.
Yeah, I see a big industry change happening in how we build software. You know, I've been doing e-commerce for a long time, and it used to be that you bought an e-commerce platform and it was meant to do everything. And if there was something that it didn't do, you had to learn how to write a plugin specific for that system, install that plugin on your server, and it kind of lived within that ecosystem of that one software platform. You had to buy the one that was most complete because it was a pain in the butt to get it to work with anything else. And headless is just flipping the script. It's saying, we're going to put developers first. They are first-class citizens, and development is going to be easy. And combining different pieces of software is going to be easy. And, you know, changing this means that you can pick every piece of software you want to use for your project and put them together. And the last bit you need is that little bit of glue that kind of ties the different pieces together. And there's small pieces of functionality, and I do think they fit really well in serverless because, you know, you're not building this big process anymore. You're just building those small pieces that connect the services you chose. So,
great, great. My last question is, says, do you have any kind of tip or suggestion? I know Nick shared some of the blog posts. What if somebody wants to start building some serverless applications, or someone wants to play around with our Commerce Tools APIs? Do you have any tip you want to share to play around with our platform or to start the serverless development?
Yeah, Nick built that entire plugin for serverless framework. And part of that open source repo, I was really happy to see an examples folder that you can clone down, and you have some code that you can just start playing with. It does involve setting up your AWS account and signing up for like a free Commerce Tools account, but you can start using those examples. But any other thoughts, Nick?
Yeah, that's a great starting point. Just download the serverless plugin repo from GitHub and start playing with examples. Play it to AWS or GCP and put some data and commerce tools. And then the next step would be you can check out the links on that last slide to our tech blog and other links there where you can get into some more complex recipes like working with augmented reality or smartwatches and the Internet of Things.
Yeah, great. Great. I think maybe we could also add, Kim, maybe we could also add those blogs link in our stream. So that would be great. Yeah, thank you very much. It was I enjoyed having a talk with James and Nick. It was a great.
Yeah, I mean, thanks, James and Nick. Very glad that you are here virtually with us in Berlin. And thank you, Anil, very much for organizing all of this. And of course, after this, I'm going to post every single links of Nick on the comment section, so it's accessible to everyone. So very glad. It was a great, awesome talk, by the way, and very glad to be able to host Serverless Berlin. So for any of you there who's a fan of Serverless, please contact Anil, and then Commercials will be very happy to host you and to provide the technical infrastructure for the group. So that's it. Let's wrap it up, and I wish everyone a good afternoon and a good evening, and for Anil, a good night, probably.
Yeah, thank you.
Okay, then bye, everyone.
Thank you. Bye.
Thank you. Bye.